Hi class, it's me, Mr. Morris. This is our third set of notes in AP Chemistry. Classification of matter. I'm going to label it 3 up here at the top. Alright, we want to talk about classification of matter now. I know this is something we talked about in pre-AP Chemistry, so it's a review, but it's important to go back through that and make sure that we completely understand it. I honestly think this is one of those topics that's harder the first year by far because you don't really know the difference between an atom and a molecule as much as you do now. Now you get that because you've already seen it. So you know what a covalent bond is, you know what an ionic bond is, you know what monatomic or diatomic atoms or elements are. So let's get started. You start at the top. Anything that has mass and takes up volume is matter. So then the question becomes, is the composition variable? Is it a different type of substance as you look throughout it? If it's got a variable composition, or you could say that you could change the amount of substance without changing its properties. You could change the ratio of components without changing its properties that much. That is a variable composition. Then it's a mixture, and we can break mixture down a couple different ways. If it does not have a variable composition, the only way to change the ratio of components within this matter that we're talking about is by breaking bonds or by changing what the substance is, and then all of a sudden the properties are very different. Well, that would be a pure substance. Okay, and we can break pure substances down further. So a variable composition means you've got a mixture. If it's got a fixed composition or it's not variable, that's a pure substance. Now, once we find out it's a pure substance, we know it's either an element or a compound. It's an element if you cannot separate it into a simpler substance with a chemical change. In other words, you can't separate it any further without doing a nuclear reaction. That's an element. Okay. If it's a compound, you can separate it by doing a chemical change. So we can chemically separate it into simpler substances. And then we've got our picture representations down here. Now this is kind of grayscale, but we've all got, this is supposed to all be the same type of atom. They're just moving in different layers. If it's all the same type of atom, that is an element. Helium is an example. And then we've got pure water. That word pure water is kind of key because it tells us that it doesn't have any impurities in it. If it has impurities, then it would actually be a mixture because it's got something other than water in it. Okay. Now let's go to the other side. What about our mixtures? Well, if it's uniform throughout, then it's homogeneous or homogeneous. We could also call this a solution. Okay. An example would be tea with sugar or sugar water, salt water, something like that. Okay. And then if it's not uniform throughout, it's heterogeneous. So that means it might separate into layers, or there would be chunks of different things without it that they separate out. They're not spread out evenly. So something like wet sand in this case. And you can see that there's a barrier or a boundary in this case. You could say there's a barrier or a boundary here. If you look right here, it's kind of separated right there. But they're scattered all throughout evenly in the other ones. So with a heterogeneous mixture, if we're looking at the molecular level, you will see that there is a boundary in that, in the picture, when you're looking at a molecular picture, a very, very small picture. Okay. There's no boundary in this one. That's the difference if you're looking at the molecular level between these between these two different types of mixtures. Or we could say that in this case it's evenly spread. Molecules are evenly spread out, and that's the key there. Let's go down here. Classification of elements and compounds. So we can actually go a little bit beyond what we did before. If we start with pure substances, so we've already identified it's not a mixture, it's a pure substance. You can have elements or compounds, we already said that. Okay, and we could go back to that flow chart we just talked about to discuss the reason why or discuss what the difference is. These can be separated chemically, these cannot. Well, let's look at the pictures to tell the difference between atomic, molecular and ionic elements and compounds. So an atomic element, that just means that it's a lone atom, okay? So you see that each of these atoms is a standalone. There's no bond. There's no covalent bond holding them together. They're lone atoms. Okay, these are molecular because they're molecules. There's a bond that's taking place there, a covalent bond. Okay, these are your diatomics, like oxygen, O2. Okay, there's actually 7 diatomics, and you can look at the periodic table to find them. The trick that I like to use is you always have to include hydrogen no matter what. So we've got hydrogen, that's the first element, and then after that you go to 7 and make a 7. So you look at element number 7 and then follow that across until you get to the halogens and go down. It makes a 7. There's a total of 7 diatomic elements, and they are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Count them. 1, 2, 3, 4, 5, 6, 7. Go to 7, make a 7. Those are your diatomics. Okay. I also want you to know this is something we didn't talk about in pre-AP chemistry, but there are some elements that can have a different combination, a different form. It could be polyatomic element, a polyatomic element. They've got different names usually. One of the examples of these is ozone. So I'm kind of running out of room to write it here. I'm going to write it here and draw an arrow over, but these are called polyatomic elements. Like ozone is O3. Then we've got phosphorus. Sometimes phosphorus comes in P4. And then sulfur, one of the most common forms of sulfur is actually S8. Okay, so these are all molecular. The most common ones are diatomics. Molecular elements like diatomic elements. But there are a few polyatomic elements as well. So I just want you to be aware of that. We can have an atomic element, a molecular element, can include either diatomic or polyatomic elements. Okay. Over here on the right hand side, when we're talking about compounds, we could have a molecular compound or an ionic compound. There's another word for molecular that you've learned, and it's covalent. Okay, so you can write the word covalent right here. A molecular compound has covalent bonds. An ionic compound forms not molecules but formula units. That's a key term that you want to make sure that you know. All right, last thing on classification of matter is separation of matter. So there's different ways that we can separate these. We can use physical means to separate a mixture, or we can use chemical means to break down compounds. And you can look at the details here and figure out what type of substance specifically is going to be good to separate. This one, it says separating solids from liquids using a porous barrier, small holes like a filter or a strainer. It gives some examples of this. This would only work if it's a heterogeneous mixture. Okay, so filtration does not work for solutions or for homogeneous mixtures. It separates out components of a heterogeneous mixture. Sorting, that's only going to work for heterogeneous mixtures, because if you can't see the difference, you won't be able to pull them out. This does not work for a homogeneous mixture. Then we get to crystallization. This is a method that we can use to separate out components of a solution or a homogeneous mixture. This can be used for a homogeneous mixture. It could probably be used for separating a lot of heterogeneous mixtures too. But this is the first one we've come to that could help us to separate a homogeneous mixture. Distillation, that's another way that you can separate out a homogeneous mixture because it deals with the difference in boiling points of the components. Chromatography, that can be used to separate a homogeneous mixture as well. All right, chemical means. So that was all for mixtures. When we get to compounds, breaking them apart, there's a lot of different methods. We just have a couple common ones right here. And these are probably the two that we talk about the most anyways. Electrolysis is breaking down compounds using electricity. So it's like splitting water into hydrogen and oxygen. And combustion is when you break something down by burning it. All right, and then we've got filtration, distillation. You've got your apparatus right here. Those are probably the two most common ways of separating a solution. So we've got the apparatus drawn down here for you to look over that. We're going to go into a lot more detail about these things later, but it's important right now that you get the basic concept of classification of matter and how that you separate elements, or how you separate either compounds or mixtures.